Assalamualaikum warahmatullahi wabarakatuh and good morning.
Waalaikumsalam.
Okay, so welcome back. This week we are going to continue with loop logic structure. Okay, hopefully everyone still remember. Okay, before midterm break, we already covered two from three major loop structure. Do you still remember, class? Okay. So quick recap. What we already discussed is the main reasons why we apply a loop in our program structure. Okay, the first one is because we want to do some counting. Counting can be 1, 2, 3, or it can be 2, 4, 6, 8, increment or decrement value. For example, in this case, if you still remember, we do the counting. Where we do the counting, class? Which part of this design flowchart we apply the counting? Which part? Which part is the counting? Anybody? Which part is the counting?
In the while loop tu.
Yeah, which statement? Which operation is the counting?
Counter +1.
Yeah, correct. So this is the counting. All right. Okay. So got it, So this is the counting. So this is required. Okay. And then we also discuss one more main reason why we apply looping in our program is because we want to do accumulating. Okay. So in this case, accumulating is this part over here. Okay. We want to accumulate the each value for each of the iteration, for each of the loop. Okay. So this is the equation, the general equation for the accumulation is total total equal to total plus x. X is the variable that we use that we want to do the accumulation. In this case, x is the age. So let's say if you have 4 age, if you still remember this one, you want to accumulate all 4 ages over here. So we apply this equation. It can be total equal to total plus age. But please remember, when we want to do the accumulation, we must put the initial value of the sum. If you use total equal to total plus age, so this should be total equal to 0. Same goes to the counting. So counting need to have the initial value over here. Initial value. All right. Okay. So that one is the main reason why we apply looping. Next, we already look at the types of loop structure. The first one is the while loop. So while loop is ada lagi. Okay, while loop is the decision. Okay, the decision on the looping is located on top of the loop body. So this is the loop body. Okay, so the decision is on top of the loop body. So this is while. Okay, this is the loop body. So how to determine which statement should be put in the loop body? So it is based on the problem given. So for example, last week we look at the simple problem to calculate the average of the age. So we identify this process is a repeated process. Okay, repeated. Enter the same category of value, kan, which is age. So we put it in the body. However, when we put it in the body, please make sure that you use the general variable name, not h1, h2, h3, h4 anymore. We just combine everything and put it in the general name. So this is the loop body. Right? And we also identify the calculation for the summation. Okay, total age is something that is repeated. Okay, so this one, we translate it to the accumulation again, the accumulation equation. So this representing this when we apply the looping. All right. So next, we already discussed that when we want to apply looping, there are three elements. Three important elements need to be put in your design. The first one is counter initialization. So this is the counter initialization. Next, decision involving the counter. Okay, counter initialization, counter decision. So this is the counter decision. We put it in the while decision loop. Okay, and then counter update. So this is the update, which is the counting equation. So these three elements is important when you want to apply the looping. Okay, and we already discussed that this is some kind of template, so you may put it in any problem that involving the looping. Okay, you may apply the same thing. Okay, just change the condition over here. For example, this one to be loop 3 times. So if you already forget how to make sure it loops 3 times, so refer back to the recording before midterm break. And then we already discussed the do while. Okay, the repeat until looping. Do while. So this is similar with while. However, we change the location of the loop decision. The counter decision. The decision, instead of putting it on top of the loop body, we move it to the bottom of the loop body. So how to identify bottom of the loop body? The bottom of the loop body should be after the counter update. Okay. If you remember, counter update should be the last statement in the loop body. So this is the loop body. You see the arrow comes back up. So this is loop body. Okay. If you draw a circle, you may draw a circle over here. You see the circle. If you see any circle in the program design, meaning that it is a loop body. So counter update should be the last statement in the loop body. Okay, meaning that this is the bottom of the loop body. So when we move the decision to the bottom of the loop body, it should be after the counter update. Okay, so this is do while. Okay, do while. We cut and paste the decision at the bottom of the loop body. And we replace the original location of the decision with the statement do. Now it becomes do while. Okay, and we already discussed that compared to the normal while, if we apply do while, although the condition is wrong, okay, the compiler will enter the loop body at least once. Kan? Although the condition is wrong, for example, the condition over here is 5 or 4, kan? 4. So this is false, kan? Okay, this is false. because counter should be less than 4 for it to enter the loop body. But if you apply the do while, although the condition already false, it will enter the loop body at least once before it falls. Okay, compared to normal while structure, although if the condition is false, okay, this is false, it will not enter the loop body at all. So it will go to false and exit. Okay, it will not enter the loop body at all. So that's the difference. Okay, hopefully everyone still remember. If not, then refresh back by looking at the recording video. Okay, and the thing that we discussed before the midterm break is loop stopping criteria that is defined by the programmer, defined by you. So user doesn't have control for the loop. Meaning that if you design the program to loop 3 times, then user have to run the program 3 times exactly. Okay, the same program 3 times. For example, this one we design it to loop 4 times, so user doesn't have control for the loops. Okay, they cannot they couldn't run the program, for example, for 1 loop only, and then they want to exit. No, cannot. They have to run exactly 4 times. So this is what we already discussed. Okay, the stopping criteria is defined by the program. Okay, by the programmer lah. Okay, so today we are going to continue first with the third loop logic structure. Okay, so we are going to continue with the third loop logic structure, which is the automatic loop. Okay, or we refer it as for loop. Okay, for loop is actually equivalent with while loop. It is equivalent in terms of the flow. Okay, the flow is equivalent with while loop. However, the design is slightly different. Okay, for automatic loop, okay, so this one I want to compare it side by side. So this is we have the normal while loop, and we want to compare it with automatic loop. Okay, so automatic loop, of course, we have start. Okay, and then we have the initialization. However, for automatic loop, the 3 elements, the most important elements, this one, the involving the counter. These 3 elements, initialization, decision, and update, is combined and put together in a single decision, single symbol, okay, which is this symbol over here. Okay, this symbol. So what should we put inside of this symbol? First is cannot use this. Maybe I use different shape to put it inside. Okay. All right. It should be the variable that we use for the counter. Okay. For example, the variable for the counter, we use counter. Okay, the same. Variable, as we discussed, it can be anything, any name. For the counter variable, you can put it any names. Okay, counter. Okay, first you put the variable name inside of the symbol, and then we put class. Are you with me?
Yes, sir. Yes.
Yes, sir.
All right. Okay, next we put the initial value of the counter. For example, over here, initial value is 0, right? So we put initial value 0, okay, to the left of the symbol. And then we put the maximum value of the looping, which is related to this over here. Okay, so the maximum value of the counter, meaning that the stopping criteria. Okay, so we want our counter to loop 4 times. So it should be 0, 1, 2, 3. Okay, including 3 lah. 0, 1, 2, 3. So if you want to start with 1, this one should be 4 lah. But if you want to equivalent with the while loop over here, so it should be 0 until 3. So it will repeat 4 times. Alright. And then the third element, which is the update. Okay, we have initialization, we have decision, and then we must put update. Update over here. So update meaning that the value that we add for the counting. If you add +1, meaning that this one should be 1. Okay. So 0 plus 1, 1, and then 1 plus 1, 2. So the update value, the update value, we put it over here. Alright, so that's it. So the 3 elements should be presented in a single symbol. Okay. So next is the loop body. The loop body will start over here. Okay. Okay, if this is true, so same. If this is true, so what should be in the loop body? This one and this statement. So this is the loop body, and loop body will end it over here by this symbol over here, circle. Okay, and then within the circle, we write down the counter variable. It is not this big lah, okay, but I want to include the flip pula besar ni. Counter, okay. Make it smaller, Circle. Okay, circle lah, circle. Alright. And then, okay, so it doesn't read like this, true and false. Okay, it read like true, enter the body, and if false, it will go over here. Meaning that if it is false, okay, somehow it will jump over here and it will not enter the body at all. Okay, so let's say if let's say somehow the decision is false, so it will not enter the body at all. So it will skip and go here. That's why we put counter over here. So if it is false, it will start over here and move outside of the loop body. Okay, so the loop body over here, the loop body remain over here from here until here. So this is the loop body. But if let's say it is false, where it go? It doesn't go over here. There's no arrow comes out over here. So if it is false, it will start over here. False and go outside. Understand, guys? How to read this? Meaning that this is the starting point for the false. So if false, it will go here, here, and here. The same as the while. The same. Okay. Okay, this is automatic loop, or we refer it as for loop. Any question? No? No question? No question,
No, sir.
All right. So if let's say we have a problem like this, Okay, a problem like this, meaning that we already know how many loop our program should have. Okay, for example, in this case, the program should be looping exactly 4 times. So we already know that. So the most appropriate types of looping is the automatic loop, okay, to be used in this kind of problem. If we know exactly how many types, how many loop the program should be run, the most ideal loop structure can be used is automatic loop. But we can also use while and do while. But the most appropriate, if the question asks you, the most of which loop structure is the most appropriate to be used if we know exactly how many loops in our program. So the answer is automatic loop. Okay, the automatic loop. All right. Because that's why the name is automatic. Because automatic. So user doesn't have any control. Okay. So the algorithm for this, you may refer to the lecture note. Okay, so this is a general, general flowchart, with the label. Okay, you may read this. And for the algorithm is like this. So this is the keyword. Okay, the syntax. Okay, the compulsory keyword to put if you use automatic loop. You must put loop, and then you must put the counter name. Okay, counter variable name. In this example, the counter variable used is C only. Okay, and then you see over here we have loop n. Loop n is over here. Okay. If you use counter for the name, then put counter over here. Counter, and this should be counter. This one, Alright. And any instruction within the loop body, we put it in between the starting and the loop end. Okay. Example, this one, okay, this is to calculate 3, 3. So if we have 4, okay, for example, in our example, we have 4 and enter age 4. So it should be 0 lah. 0, 1, 2, 3. Right? So this should be 0. Okay, you see loop counter 0, 2, 3. Okay. And then this is the loop body. And this is the loop end. Okay, ended at the counter. So if this is false, it will start over here. False. What happened? Okay, clear? Eh? Is it clear?
Clear, sir.
Yes.
Yes, sir.
Okay, so we covered all three major loop structure already. So this is the important part. This one. The three structure, the most important in the loop logic structure we already cover. Okay, next. Okay, next we are going to look at the stopping criteria. Okay, the stopping criteria, the one that we already covered is the automatic part, okay, defined by the program. Next, we want to look at how we want to design a program with a looping that is controlled by the user, meaning that user determine whether they want to repeat the program or they don't want to repeat the program. Okay. Okay. For example, in this case, instead of entering the age 4 times, it is up to user to enter how many age. Okay. So there are more than one way to do this. So I'm going to show you one of it only. Okay. The rest you may, if you want to design other, if you want to use other stopping criteria technique, you may try to discover it by yourself. All right. So clearly, the important elements is involved over here. Okay. If you want to, this one is used to control the loop. Okay. This is used to control the loop. So we need to modify it over here. Okay. If you want user to have control for the program. Okay. So defined by the user. Okay, first is the initialization. Okay, so let's say we start with counter 0. Okay, boleh So let's remain it as counter 0. Initialization Then later on we look at other value that we can put over here. Okay, next is the decision. Okay, for us to make user have a total control, so most of the time this decision over here should complement the initial value, meaning that this should be always true. Okay, counter 0 and then this one should be counter equal to what class? If you want to make it this true, counter equal to 0. Okay, counter equal to 0. So it will always true for the first time, Okay, for the first time, it will always true. Okay, until over here, this one is automatic. So to make it user define stopping criteria, we change this to, okay, we change this to input value. All right, input value, which is enter what class? We ask the user to enter whether they want to exit or not. For example, enter 1 to exit, enter 0 to proceed. Okay, or enter 0 to repeat. So enter what class?
Counter, sir.
Correct. Okay. Okay. Meaning that if user enter 0, what will happen? The program will repeat again. User enter 0, program will repeat again. User enter 0, repeat again. 0, repeat again. But if user enter 1, what will happen? User enter 1, counter equal to 0. So now counter is 1. So what will happen? It will become false and exit the looping. Okay? Understand, class? This part first, This part first. Understand?
Yes, sir.
Alright. So, but how about this equation? Can we use the same equation as the earlier defined by program structure? Can we use this?
Cannot.
Of course we cannot, kan? Because user enter 1 over here, kan? So cannot use sum divide by 1, kan? So let's say if this program already repeat 5 times, kan? User enter 1, so it repeat, user enter 0, it repeat again. User enter 0, repeat again. User enter 0, repeat again. And user enter 1 because they want to exit. So exit and then sum divide by 1. No, man. It's supposed to be divide by 5 lah. If it repeat 5 times, kan? So how we want to modify this? This is one way, this is one way to do it, I said there are more than one way to do this one, kan? So you may put, okay, you may use different variable, okay, different variable. Okay, for example, we use, okay, this is for the counter, and then for the counting, okay, the most important thing is counting, kan? Counting, because we want to count the looping. How many loop, kan? 1, 2, 3, looping, counting, So use different variable for the counting. Okay. For example, what variable, number lah. Let's use number. So we add one more. Okay, if you want to use, if you want to make it user control stopping criteria, so we need to add one more variable for the counting process, for example, number, for the counting. So it should start with, okay, let's say we start with 0. Okay, look, let's say we start with 0, then we look what will happen, Okay, so this is counter update, should be at the bottom of the loop body. Okay, so the counting is somewhere over here lah, whether you want to put it here or below, anywhere, okay? It can be before accumulation or after accumulation, as long as it doesn't affect the program, So what is the equation, guys? Number equal to, for the counting, what is the counting equation?
Number plus 1.
Correct. Okay, good, counting. Right. So it will count and it will count. So this should be number. So my question is it correct? If we start with number 0 and you want to use number as the equation to calculate the average, is it correct, this value?
Correct, sir.
Wrong, sir, wrong.
Okay, let's say you want to loop 4 times, Okay, so we need to use this table again, Let me call again this table. Sudah. We have counter, we have number, hilang lah age. Siapa pula guna word ni baru lah sini We have counter, we have number, we have sum, we have age. Okay, so counter 0. If counter 0, number 0. Okay, what will happen? So counter 0. Okay. So it will enter the loop body. So user enter age sum 0 Okay, sum 0. Okay, this one we doesn't did anything Sum 0. Okay, so enter the body. So age user enter 2 for example Okay. And then sum equal to 0 plus 2, right? So now in the first loop, sum, this is the first loop Let's say this is the first loop. So in the first loop, sum become 0 plus 2, which is 2. In the first loop, number become 0 plus 1. Okay? 0 plus 1. Which is 1 Okay? So in the first loop, over here, user enter counter equal to 0. Okay, because he want to repeat the program. So if we repeat again, now in the second loop, so this is the second loop, user enter H3. Okay, for example, user enter H3. So let me use this value first stress So user enter H3. This is second loop So this is first loop. This is second loop. Okay, second loop. User enter H3. And then sum. What's the value for the sum? Second loop. What's the value for the sum?
5.
Yeah, correct. So 2 plus 3. Second loop This is the second loop. So 2 plus 3. Now the value is 5. What's the value for this in second loop?
2.
Okay, 1 plus 1. Now it becomes 2. Okay, user enter counter 0. So it goes back again. 8, 0, true. Okay, user enter H. User enter H. Sampai betul pula. User enter H. User enter H. Apa This is continue 2, this is 5. User enter H4. For example 4. So 4. Okay. And what's the value of sum?
9.
Okay. It's supposed to be, the value of sum is 9, kan? Where's sum? This is sum, Sum is 9. What's the value of number? What's the value of number?
3.
3.
2 plus 1. So it becomes 3. This number, over here number. And then user enter counter again, user enter 0. Because user want to enter 4 each. Okay, 0. Okay, user enter age again. So this is the for loop. Okay, 0, 3, 9. Now user enter, let's say age 2, Okay, user enter 2. And what's the value over here? What's the value over here?
11.
11, correct. So now sum become 11. What's the value over here?
4.
Okay, good. This is become 4. So user enter 1. Because we already got 3 each, kan? 1, 2, 3, 4. Sorry, we already got 4 each. 1, 2, 2, 3, 4, 2. The value of each, because we want to match with the original, kan? But this time user have a control, If user enter 0, it will repeat again, kan? But this time user say, oh, it is enough. Okay, I already enter 4 value of age. So I want to exit the loop. So user enter any value lah other than 0, kan? If user enter 0, it will repeat again. So user enter 1. Okay, user enter 1 to exit the program. Of course, over here you need to guide the user, So there will be a command. Enter 0 to continue. Enter 1 to exit, for example, So user enter 1 over here. So 1 is false. So 1 is not equal with 0. So 1 is false. Now it goes out. So sum divide by number. So number value should be what class? In order for it to be true. In order for this equation, this design to be correct, number value should be 4, kan? So let's check out the latest value of number 4. Okay, so meaning that this is correct, This design is correct. Okay, start with 0. Okay, understand? Okay, so this is correct, Correct, Any question?
No, sir.
Okay, so this is how to design a stopping criteria that is defined by user. Okay, as you can see, there are a few items that you need to add to your design compared to the defined by the program design. So same goes to the do while. For the do while, so just add all the elements that you put it over here, and then it will become stopping criteria that can be defined by the user. Okay, so for this one, I'll let you do by yourself. Okay, later on. No question, So if no question, no, Okay, so this is suitable, defined by the user stopping criteria is suitable for while and do while. Okay, it is suitable for while and do while, but is it can be done for the automatic loop? Stopping criteria defined by user. Can we do it for the automatic loop? The answer is yes, but I'm not going to show you. Okay, for now, later on, next semester when we learn about programming technique, then maybe I will show you. But for now, we are going to stick with if the stopping criteria is defined by the program, which is automatic, it is suitable for you to use automatic loop. Okay. If the stopping criteria is defined by the user, okay, it is not appropriate for you to use for automatic loop. Okay. Understand? But for both condition, okay, defined by the program and defined by the user, you may use either while or do while. No problem. Okay. For both condition defined by the program and defined by the user, you may use while and do while. For automatic, use defined by the program only. Understand? Confused? Okay, defined by user, while, do while. Defined by program, automatic, while or do while. Yeah, yeah. Okay, defined by the program, you may use any three of these. It is suitable, For defined by user, use while or do while. Don't use automatic. But can you use automatic? Yes, you can, but not appropriate. But can, no problem, Boleh? Apa ni? Tak se. Apa Muhammad Naim? Any question? Muhammad Naim? Apa yang tak ni? Muhammad Naim? Okay, dah faham. It's okay if you don't understand, please ask me. Please ask now. Don't wait until exam. If you don't understand, please ask now. Okay, if no question, then let's move on to this one. Like we go back. Supposedly we must do the PAC kan? PAC IC IPO kan? But I'm afraid if I go to PAC first, then you will get confused. IC IPO, because over the PAC, if we refer to this node, the PAC, you need to put the looping element in the processing required. Okay, you need to put over here. You see, there's a, if you use do while, you put do while over here. Okay, for the PAC same goes for the IPO. So this is similar with the decision PAC. If you decision PAC, you need to put the decision in the processing required. So same goes to the loop. You need to put loop element over here. And for the IC, nothing to show over here. Okay, you see this one is for repeated, but for now, let's not use this first. Okay, later on when we discuss about next chapter, then we will look at this one. For now, let's remain with this first. Okay, for now. Later on, we are going to change. Okay. And this is the IPO. Okay, as you can see over here, we have the do while. This is the do while. If it is while over here, while. Okay, we put it in the processing part over here. Okay. And later on, we are going to look at which module should put over here. That one is next chapter. Next chapter, when we learn about modules, then you will have a clear view why we need to put read over here, one calculate over here, one calculate. This is not entirely correct over here. Later on, I will show you the correct module to put over here. But for now, let's just stick with this one. Okay. So PAC and IPO need to put the looping elements, same like the algorithm. This is same like the algorithms. And what is important, I'm not saying PAC and IPO not important, but it is the same. The most important, other than the three types of loop structure, is the dash checking. Okay, the dash checking for the loop logic structure, in case you have it in your design. So let's look at this example. Okay, for example, we have this design. This is to calculate the square value. The square value. Okay, this is to display, just display. Display x and x square. Display the text. The text only. The text only, not the value. Display x square to the screen. Okay, and then if we use automatic loop, okay, the for loop. So we want it to repeat 3 times. So this is automatic loop. The stopping criteria is controlled by the program. So this is the equation. Okay, to get the square value, and this is to display the value of x and the value of square value. Okay, and then repeat 3 times. 1, 2, 3. So how to design the dash checking? Of course, you need to have the test data. Sometimes the question asks you to come up with your own test data. Sometimes the test data is given to you. So let's say if you have to come up with your own test data, then just pick up the most basic value lah. For example, 1, 2, 3. So you will get, you don't have to calculate it. You don't have time to calculate the required output. Why is it the input is none over here, class? For the test data. Test data should have input and output, and why is it none in this case? Input is none. Any idea why the input is none?
Because the algorithm don't have input.
Correct. Okay. Input over here means input by the user. So user doesn't have to enter any value kan over here. You doesn't see any enter keyword over here kan? Or input keyword. No, right? Meaning that user doesn't have to enter anything. Okay. No, kan? User just run the program and the program do everything kan. So no input. The one that we have is only outputs. Okay. So how to design the dash checking? Okay. First, of course, we have the line number and then list all the variables. In this case, we only have 2 variables, x and x squared. So if we have 10 variables, list all 10 variables over here. Next to it is the conditions. So this is the same as the decision. So this is shared. Okay, shared by the decision and looping. Okay, shared. Looping use this column over here. Decision also use the same column over here. So if you have looping and then inside here you have decision, don't put condition for decision, condition for looping. Just put condition only. So this is shared. All right. And input and output. So don't forget about this. Okay. Okay, so here in line 2, okay, line 2, nothing kan, just display the text, not display the value kan. That's why you see this one, double quote, meaning that this is a string value. This is a string value. We just want to print it so that later on in the real program, user will see this some kind of table lah. This is the title of the table kan, not the value of the x and x squared, just the title of the table. Okay, next in line 3 we have, okay, line 3, don't forget for automatic loop over here we have counter initialization and decision and also update. But I'm going to show you that update, when it comes to the dash checking, we put it in line 6. Line 6. Okay, later. But for now, in line 3, we have counter initialization and counter decision. That's why over here we have, sorry, this is missing one more, which is counter. Supposed to be x. Why this is x class? So what should we change over here? Seems that this algorithm is incorrect. It is incorrect algorithm. So this supposed to be what class? This is supposed to be? Anybody?
X.
Correct. So this is wrong. This algorithm is wrong. This is supposed to be x. So it seems that this program use counter as the x value. As this x value to calculate the square. So it use the counter. So x is the counter lah class. So when you design it, you need to put x as the counter for this program. Another one is over here. So the counter is x. It is the same value that we use to calculate the square. Alright. If you use counter, then this one need to change to counter. And this is, let's say you use counter over here. So this is a counter, counter by counter and then this is counter. Okay, in this case, in this problem only. Okay, so we have this. Now it is correct. In line 3, we have initial value of the counter is 1. Okay, so 1. And then we have the decision. The decision is 1 less than or equal to 3. So true, it will enter the body in line 4, do the calculation. And then in line 5, it display the value. Okay. And in line 6, we do the update. Okay. This is the counter update. Okay. X plus 1 lah. X1 value, so update by 1 kan. X equal to X plus 1. So it become 2 and it will goes up again. Check the condition. If the condition is true, it will enter again. That's why you see over here, it go back up to 3. After 1, 2, 3, 4, 5, 6, it go to 3. Because the flow is like that. The flow, if this is correct, if this is, sorry, after the update, it will check the condition again, whether this is true or false. Okay? Understand, class? Let's have a look at this example. So this is where user control the stopping criteria, kan? Is it? Yeah. Okay. User control the stopping criteria by inputting the number. So number is the counter, kan? If user enter, how to stop this looping, class? What number should user enter over here?
A negative number.
Correct. Negative number, kan? Because as long as the number is 0 or more than 0, it will loop. So user need to enter negative number to make this decision false. So it will exit the loop. Okay, so this is the test data. Okay, meaning that we want to loop how many times? How many times looping?
3. Oh yeah, 2.
2 okay, correct, 2 So this is the stopping criteria, kan? Okay, this is looping, this is looping, this is less than 0, so it will stop. It will not enter the loop at all because this is a while loop, kan? Okay, so this is the example. Okay, you may have a look at this one. Okay, later on by yourself. Okay, and also you can look at the example of the exercise. The answer is already given to you. Exercise number 2. So this is the combination of looping and decision. Okay, looping and decision. Okay, look at this. Okay, this is the answer. Okay, look at this. And that's it, class, for the loop logic structure. So we covered everything over here already. Any question? Any question? Okay, for the lab exercise, those who haven't submitted yet, so please submit the week 6 lab exercise kan. So this is, I ask you to submit the answer in Flowgorithm kan. So you need to figure out Flowgorithm by yourself. So install the Flowgorithm. So you need to install it. Download and install the software, and then this is the flowchart software. And you can run it. You can run and see the inputs, and you may enter the inputs and see the outputs. If you didn't get the correct output, meaning that your design is wrong. This one, this is easy. 1 and 2 is easy. Just convert the algorithm to flowchart. But this one is the things that I want you to look very carefully. So this is the example of final exam question actually. Okay. So if you see over here, this is actually, is it stopping criteria controlled by user or controlled by the program class? This one. Is it controlled by user or controlled by the program?
Control
Program.
by user.
User.
Is it controlled by program or controlled by user?
Oh,
Program.
control by program.
You see, the keywords.
Period of exactly 10 days.
Yeah,
Sudah kena tetap.
the keyword is very important. Okay, when it says something like this, exactly 10 days, meaning that your program should be running, looping exactly 10 times class. So you may design it by using stopping criteria by the user, but you will not get full marks for that because user can control, meaning that user can stop until 5 days for example, because they have the control, but if you're using a stopping criteria defined by the program, then user doesn't have control for the stopping criteria for the loop Okay, so exactly 10 times it will loop, and in each looping you should put this decision. Okay, in each looping there's a decision. If a PSI 0 to 50, the category equal to good. Okay, else if PSI 51 to 100, this is the value. And you doesn't stop only for category. So you need to also calculate for each of the category class. You need to calculate so that your output should be like this. So we have 10 days. How many days is good? How many days is moderate? So this is what process class. How to get this? Is it counting or accumulating? Is it counting or accumulating?
Accumulate.
Accumulating.
Counting or accumulating? Okay, let's take a look at the some of your answer. Okay, to tengok, we start from 1A until we see the correct answer. Let's start with Ahmad Nazan. Ahmad Nazan, are you here? Ahmad Nazan. Ada tak Ahmad Nazan? Okay, I just want to see the structure, not the syntax. I just want to see the structure. Okay, let's skip this first. Let's look at the. Okay. I think this is the correct answer. This is the correct. Yeah, this is correct actually. Okay, you see in each of the iteration, so this is the looping condition for the looping. So if this is true, user need to input the PSI, and then okay, this is correct. However, this one supposed to be put at the bottom. This is supposed to be at the bottom of the loop body over here, but since it doesn't affect the program, it's still correct. But most of the time we put it at the bottom because sometimes we use it for calculation, anything lah. Okay, that's why we put it at the bottom so that it can be used in any design. Okay, but over here is correct. So if this is true, then we calculate, we add good plus 1. Of course, this one we have the good initialized with 0. Otherwise, we cannot use this. So this is a what class? Is it accumulating or counting? Is it accumulating or counting? This is counting or accumulating? This one.
Counting.
So this one is counting or accumulating? Is it similar, guys?
Counting.
Counting lah, okay. Counting If you want to count 1, 2, 3, that one is counting. Accumulating should be good equal to good plus X, for example. That one, if you want to calculate the accumulation of X, okay, accumulation will have something like this, good equal to good plus another variable. If you see your design something like this, this is a counting. Okay, we want to count because the purpose of this program, you want to count the good days, the moderate days, the unhealthy days, how many So it is counting, class. Don't you get confused with this. So this is correct answer. Okay, so this is how you write down the answer. Very simple actually. But some of the students get confused. So how to do the counting? First, you need to do initialization. Initialization, same like the counter update. Counter update is the counting. So you need to initialize value. Okay, put the value 0, 0, 0. Otherwise, you cannot calculate it for the first time. It doesn't find what is the value of count plus 1. What is the value of count? So we need to give initial value, which is 0 to start the counting. Okay, class? Understand? So this is the answer. So this is the correct answer. Actually, very good. Kita tak tahu ni, Nazhan ni ada sini tak ada. Senyap je. Okay. So this is the decision for the looping. So inilah, ni looping. Through repeat again, repeat. Okay, good. So those who haven't submitted yet, so please submit. Okay, please submit. Okay, any question regarding this exercise, class? Dah jumpa kan? Dah jumpa jawapan yang betul lah. Betul lah ni. Okay. So don't put the print Don't put the print good, print moderate, print unhealthy inside of the loop. If you put it inside of the loop, it will print many times lah. It doesn't follow the instruction. The instruction shows the output example one time only. Good print one time moderate print one time. If you put it inside of the loop, it will print this 10 times. Okay, we have good, moderate, unhealthy hazardous, and then print again. Good, moderate, unhealthy hazardous, print again good 10 times if you put it inside of loop. That's why we put the print outside of the loop. So we get exactly like this output example. Okay? Question? No? Question, no? Okay, if no question, then I would like to brief you the mini project. Okay, you may find the question from column. Okay, find the question and template in column. So for the question is, so this is 90 marks. Okay, from 90 marks, it will contribute 30% of your overall coursework marks. 30% is very, it's a lot class. To pass this subject, you need 50%. So 30% is a lot. So if you get full marks, so the probability for you to pass the subject is high lah. 30% is a lot. So there's a rubric you need to follow. Okay, at the bottom of the question, the rubric is given to you. So how to get full marks? Just follow the rubrics. Okay, for example, the rubrics the rubrics algorithm, you should have algorithm without module. So you put it in your design. So you get full marks to 7. If you put dash checking is correct, so you will get full marks. Okay. So this one we haven't discussed yet. So this one is in the next chapter. Okay. But you may start with the basic. Okay, for example, the PHCIC, you may start first. Okay. So that one is rubric. Okay, what you need to submit is the project report. Okay, refer to the template, the C file, okay, the coding file, and the presentation slide. Okay, and for this project, it is done by groups. Okay, it is done by group. So in one group consists of 3 members minimum. So you cannot have 1 or 2. So it should be 3 minimum, and maximum is 4 per group. Okay, it is up to you to select your group members. Okay, group members is up to you, and you may conduct your group discussion through online medium such as Google Meet, any medium lah. But the important thing is you must record all sessions of the discussion. Okay, and upload the recording to YouTube. Make sure you upload it at the same date that the meeting happen. Don't wait until the end to upload everything, because I will refer to the upload date. Okay, for the marks, there's a mark for for this, for the meeting. So what is the task? Each group need to propose a title from real world problem based on the ministry department. Okay, the ministry department you may find over here. Okay, ada tak? Ni ni ke? Menteri. This one okay, this one if you follow the link, you will go to here. So for example, this one is finance. This is defense and so on. So based on this ministry department, I will assign you. Okay, I will assign each group with a specific ministry department. Okay, it is not up to you, it is up to me. Okay, it is up to you to choose your own group members. It is me to determine which ministry your study your study will go to. And then let's say if your group is assigned with the Ministry Department of Finance, and then it is up to you to find a suitable program to be created in that particular ministry lah. Okay, you need to find a suitable project that is related to your ministry department. Okay, so each group will not have the same topics because it is each group will have different ministry departments. All right. So you need to write down the case study 2 pages. So this one refer to the report template. Okay, over here, the template. Okay, let me just briefly show you the template. Okay, template over here. This is your picture, name and picture. Okay, so this is the template, case study 2 pages. Okay, just follow this. You need to have all these things. And then coding, interface prototype. Okay, interface prototype is you may use anything. Anything to visualize how, let's say if you want to make a mobile application, although we use only black and white, this is coding, the coding is on black and white only, the output, but let's say if you can have a proper interface. So how do you want your program to look like? For example, you want to create something like Maybank to you, for example. So provide at least 3 interface. How you wish your program to looks like. You wish, not you have to develop the real interface. Just use any. You may use Microsoft Paint. You may use PowerPoint to design it. It's up to you. All right. And next is, so your program should have at least 3 decision symbol and 1 nested decision. Okay, and at least 1 looping in your design. You have to apply at least. Okay, so you cannot use any case study that already discussed in the class or in the lab exercise or in the lecture notes. You cannot use it. Okay, meaning that you have to come up with other than that. Okay, provide example of expected output in your case study. Okay, this is in the case study. Okay, and submit your report before the presentation in week 14. Okay, that's it. It is quite simple explanation. Only 1 page of instruction. Okay, but the important thing is the rubric. Follow the rubrics. So what's next? So next, I will provide a. you may ask around for your group members, and then by this week, I will provide a link for you to write down your group members. Okay, I will give you due date for fill in the form. Okay, later on, once the form is closed, I will provide each group with the specific ministry, and then you may start discussing what should be the topics for your groups lah. Any question, guys? Alright. For the group members, you may cross, for example, section 1A with 1B. Okay, you may do that, but section 1 should be within section 1 only. You cannot cross section 1 with section 2. Cannot. Section 1 and 1A and 1B can be in one group, but section 1 and 2 cannot be in one group. Okay, that's the requirement of group members. And degree only. Diploma student with diploma student only. Cannot mix diploma and degree in one group. Boleh Okay, any question about the mini project?
No, sir.
No question. Wait Class, do you have any lecture on Tuesday night next week? Or test? Anybody have lecture or test next week, Tuesday night?
No, sir.
Anybody?
No.
No, sir.
Okay, so this is your attendance. If no question, then fill in the attendance, and that's it for today. Okay, thank you. Assalamualaikum.
Thank you, sir.
Thank
Thank
you,
you,
sir.
sir.
Waalaikumsalam.
Thank you, sir.
Waalaikumsalam.
Thank you, sir.
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 Thank you, sir.